Okay, today I'm going to give you just a little, tiny little taster lesson about the moon. Um, so the moon is the most prominent thing we can see in the night sky when it's visible. Um, we can almost be so dismissive of the moon because it's always there, just it's the first thing that a small child will recognize in the night sky. But the moon is absolutely fascinating. Now it looks spherical, but like the Earth, we call it an oblate spheroid, which means, if you think this is the lunar disk here, this sphere is a bit squished on the top. So imagine a beach ball and just pushing down the top. So the diameter from the center of the moon to the lunar equator is larger than the diameter from the center up to the polar region. And this is about 4 kilometers less than this. It's not much given the size of the moon, but that means it is not a perfect sphere. The moon has no atmosphere, and this is because the moon is so small, it doesn't have enough gravity to be able to retain an atmosphere for a planet or a satellite to be able to have an atmosphere. It has to have enough gravity to be able to hold that atmosphere in place, and the moon doesn't have one. As a result, there wouldn't be any liquid water on the moon because the atmospheric pressure is so low, that water would just boil off. Even if you were to take some water up to the moon, it not be freezing, it would just boil off because there's no atmosphere there. The moon is heavily cratered, which is obvious. We can see that from looking at it. Most of these have been formed by meteorites hitting and bombarding the moon. If the side that we see of the moon, which is interesting, we only actually see one side of the moon. There's the other side, the opposite side, what we call the dark side of the moon, which isn't actually dark, it does get sunlight, is even more heavily cratered. It looks so different to the side that we see here. And there's different features here. So let's talk about these different features. Astronomers, when they've looked at the moon, they've seen there's about 30,000 craters. And some of them are really big. Some are as large as 100 kilometers across. So we've got these impact craters, which were formed by meteorites hitting the moon in the past. And they've been given different names. They're usually named after mathematicians or philosophers, for example, Plato, Pythagoras, and Kepler. What happened is when the moon was bombarded with these large meteorites, they created these big craters, and we know that the moon at some point had under its surface lava. There was in its early days of being formed, there was lava under the surface of the moon, just like we've got lava today under the Earth. The meteorite bombarded the surface, and the lava escaped. So we see these areas here called which we call maria or seas, because when early astronomers looked at them, they thought they were seas, they thought they were covered in water. And now we know that this was where there was these big impacts and there was these massive big craters produced, and lava came up and then hardened, and it creates these darker regions on the lunar surface. They've been given the most beautiful names. So there's the Sea of Tranquility, the Sea of Clouds, the Sea of Nectar. They sound so poetic and lovely, but they're pretty barren. And they're flat. You see, these areas here are quite flat because you'd think about the lava coming up, flowing out, covering this region. And so this is like new rock which has been formed on the surface of the moon. The whiter regions round about, we call these highlands, the lunar highlands or terra. And they're lighter in colour. And this again comes back to the historical origins of when people were first really studying the moon. They saw the darker areas which they thought were seas, and so they thought the lighter regions were land. And so they gave them the Latin name Terra. And that means higher than the seas, higher, Terra, or higher than the Maria. Hence we call them the lunar highlands. So if you think that when I think a massive big impact from a big meteorite coming in, let's just look at this here, this region here, this gets impacted, and this impact would have created a massive amount of debris that gets spewed out, and it would cause this is where we get these higher regions, these lunar highlands being formed in these bigger regions. And then you've got all these smaller craters here, which we're going to have a look at on a better picture on this slide. So this is a lovely big picture of the moon, and you can see the seas here, the big ones here, and then these lighter regions. This here is a famous crater called the Tycho crater. We've got here the Sea of Tranquility, the Sea of Cries. This region here is a mountain range called the Apennine Mountains. Here's the Sea of Storms, the Copernicus crater, and over here is the Kepler crater. And one of the activities in the part of the GCSE curriculum is that your child would be going and studying the moon and sketching the moon and be able to identify these features on the lunar surface by looking at the moon with either the naked eye or with a pair of binoculars when the moon is full. And because you can see all of these features on the moon itself just by looking at it when it's a nice full moon. Go out and see if you can find the Tycho crater or the Sea of Tranquility or the Sea of Storms. Have a wee look for them and see what you can find.